in this lecture, we are going to discuss about the possible optics projects that can be done at home with very basic equipments. You don't need any fancy stuff, just whatever you have at home. But the idea of project is that you should be able to demonstrate the optical concept. It is demonstration plus readings plus analysis, and your end outcome is obviously result. So it is not necessary that in the beginning of the project only you know that what is the end result that you will expect, but you will have some rough idea, because the kind of project that we can do at home will be new to you. It's not like nobody has done it before, but the idea of the project is to have that hands-on experience and the joy that you get of experiential learning and the skill set that you can develop by doing projects. So what are the basic contents of any project? You should be able to demonstrate the concept, which is the heart of your experiment or project. Then you should be able to take readings, analyze that data, and you should have some, it should not be open-ended. You should have some solid result at the end of project. Now you might ask how project will be different from experiment. It is essentially the same, but you will see that in most of the universities and colleges, experiments are few in number, which are listed at the end of your syllabus. So every syllabus will have some list, let's say list of 10 or 12 experiments that will be listed. And you will find those experiments very well documented in many of the practical course books. So one which is common and which is well documented is experiment. And if you're doing any innovation and where you do not require any fancy lab setup, will be your project which is done at home. So what we are looking at is little innovation and projects doable at home. This is very important. Let me give you some examples of projects that can be done at home. I'll not start with reflection because reflection is really very basic, but we can always start with refraction, that is the lens experiments. So lens based projects. What I am giving you are only, the basic ideas. You can always innovate, improvise, and change depending upon the requirement. So how deep you go into the topic is totally up to you. So let's say I have a lens. We all know how to do basic experiment for finding focal length of a lens. But if we are changing aperture, that can become our project. So if let's say my lens looks like this from the front, and I decide to vary the aperture of the lens using some cover. Now you can do it with two ways. One is you take a circular black paper. Okay. So first our basic assembly would be, you have a lens, you have, let's say how we did in our experiment was, taking a candle flame and we tried to obtain image of it, which was on the other side. And depending upon the distance, so the size of the image was also varying. And what we measured, the kind of image formation that you got here, this you measured U, object distance, you measured V, image distance, calculated the magnification, which is V by U, and you plotted the graph between U and 1 by M, which was some sort of a straight line with negative intercept, where slope gave you 1 upon focal length value. Okay, so this is one basic experiment. Now let's see how we can modify this. Let's say these are the points that you get. Keeping the assembly same, if you decide to stick the lens with a chart paper of a particular circle, then your light entering area is reducing. It will change the apparent depth. So what you can do is keep on increasing the size of this chart paper and take different reading. And then if R is the radius of this lens, then you can start from, R1, R2, R3 being the radius of this chart paper till it reaches R. So when it reaches close to R, you have just closed the lens entirely. And then look at how the image distance is changing. Or if you happen to have a very thick lens at home, you can use your mobile screen. You can simply have your mobile screen and you can create, let's say, arrow kind of object in the form of image where this object will be colored and this entire thing will be dark. So let's say you start with a red arrow and then you take a very thick lens. So this will be your U. Let's say image is formed. Let's say your image is formed here. One second. Let's say small diminished image is formed. So this will be your V. Now, if the lens is really thick, it will undergo chromatic aberrations. And in order to enhance those chromatic aberrations, you can mask the middle portion of the lens. Just mask it from the middle so that the lens area which is having parallel glass sides will be ineffective and the curvature will become more effective. And hence, once you keep on changing the color of this and then take the readings. So you will see that if in this condition this thing is red, then if I make the object blue, then blue distance will change. If I make the object green, green distance will change. So with respect to color, this V will keep on changing, even if your U is same. And why that happens? You know that refractive index is given by Cauchy's equation, A plus B by lambda square. So mu varies with inverse to the square of the wavelength. So if your lens is really very thick, and to enhance that chromatic aberration effect, if you mask the central portion of the lens, then your mu will keep on changing with respect to wavelength and the bending power will change. Hence your V will also keep on changing. So that way, using a thick lens, you can do the experiment related to chromatic aberrations. Okay. Then moving along, you can do the experiment for single slit diffraction. We have already done. You can do, double slit diffraction or CD grating diffraction. So let me give you some examples of diffraction experiments which can be done at home. So diffraction projects. One of the most common experiment that can be done at home using this is CD. So all of you know what a CD is. If you take a CD, so if your CD is like this, you can see such kind of lines, right? So there are two ways to do experiment with CD. If you're shining light from the front without peeling off, the coating, then it will act as a reflection grating. If you're peeling off this coating, there is a coating on this. The best way to peel off this coating is simply, put a tape on this area, apply a duct tape on this area and peel it. This portion will become transparent. So this will become transparent and this area can act as transmission grating. So what you can do is you just cut this much area using, very hard scissor, which is used for cutting metals. And then this can become your transmission grating. The only thing that you have to remember is always go for the outer edge part while cutting. Why? Because as you come close to the center, the curvature start to dominate. So you will see like, if you have cut a very close portion, then the curvature is very dominant. But if you are towards the outer part, there you can get a grating which is having almost linear lines. So this will become your transmission grating. If you have peeled it off, that coating, shiny coating that you see, then it will be transmission grating. And if the peeling is not removed, as it is, you are using with coating. So with coating, it will become reflection grating. In both the cases, you can do the experiment. If it's transmission grating, it's little easier to arrange. Let me show you a simple setup to arrange. Let's say you have this as your laser and you have a very strong beam of laser coming out of it. And then you keep your this grating in front of it, and what you will see on the screen is only 4 dots. So you will see one of the dot which is your central maxima, and then you will see dots which are becoming far and tinier. So if you happen to have DVD also, then you can compare the grating constant, which is the opaque plus the open surface for CD as well as DVD. So you can do one experiment where this grating project as CD and DVD, or you can simply do CD and DVD. So measuring track width, you will get these kind of spots. Only thing here, what you need to remember is, because this theta is really huge. Okay. Here we are talking about diffraction. If you see its intensity profile like this. The only issue that you will face while doing calculation will be, now small angle approximation will not hold good. What is small angle approximation? Where we say that your sine theta equals theta equal to tan theta. That will not be hold true over here. You have to do proper measurement of theta, and that is also easy because let's say you want to know for this location, then you know this difference. So measure this x, measure this separation from here to the screen, let's say it is g. So knowing this, you can get to know theta, and then you can substitute in our grating equation, which is d sine theta equal to n lambda, which is for this position of maximum. So either do CD or do DVD or do the comparison between the two. So this was about the transmission mode. If your assembly is such that you're not able to peel off that CD. Still, there is another way to do it. Then what you need to do is, let's say you are, this is my table. Then you just stick your CD over here at the edge of the table. This is my table edge. Okay. And then here you keep your laser. This is strong laser beam, which is shiny. Align it in such a manner that it will hit the outermost portion. And then behind on the wall, you keep your screen and align it such a way that the first order is coming, somewhere on the top. So you will have 0 order, first order, like this. So still this experiment is doable. Laser will go from here and bounce back. In the previous version, what we were seeing was the transmission mode. So the pattern will be obtained on the other side. Another experiment which you can do with double slit is, you can do double slit diffraction. There are multiple ways to create double slit. And we know that because we are doing it at home, we are not looking at, very perfect result. So assumption is also okay. Now, all of you have done one experiment of single slit, which was created using razor blade. So let's say this was the slit which was created by razor blade. So let us see how to modify the same setup in order to make it good for double slit also. So what you can do is make a paper frame with a cardboard or anything such that only this much is the cavity and this entire thing is a cardboard, or even little hard paper will do, like this. So now this was your single slit. Now what we can do is we can add one more wire to it. Any small wire will do. Why we want metal? It is important because if we don't take metallic wire, then what will happen if you try and doing it with a thread? Then thread will have many sub-threads, which will, hinder with your pattern. So let's say I have this as my wire, and then you can just glue that wire to the frame. We have also done such experiments having triple slit. So it's very much doable. What you need is just, little bit of patience and be very cautious about using laser. Do not let it enter your eye at any cost. Okay. So still it's not proper. Let me see if I can move it. Now this is okay. So this is your double slit. Now, because we are making a realistic double slit, it's not that Young's double slit interference experiment. What will be the difference? You will get a big diffraction envelope in the middle and your interference will be inside this. So you might see, multiple peaks. And the pattern will, so if you are seeing only the central maxima, then what you will see is only, the peaks like this, which are separated. And then you can do the tracker analysis of the same in order to calculate your A plus B. So here, what is your A? A will be your slit width. Try to arrange it in such a way that each slit is of same width. and B is the separation between the slits, which is, essentially your opaque area. So this is another experiment that you can do. There are such many more variations. These are just few examples that I have suggested. Let me also show you one more experiment on even refraction we can do. Let us not, ditch it yet. Let's say you want to do one refraction experiment. There are two projects which are possible in refraction. One will be, simple bending of light. So let's say you have a little broad kind of container will be required for this experiment. So let's say you have here one container which is filled with water. And if you insert, let's say, a pencil or little long rod in it, then you know that it will appear to bend. And you know that as it will, if from outside, it will appear to bend towards the normal. I have drawn too much exaggerated diagram, but little bit of shift is observable. What you can do is do one without liquid and do one with liquid, and then capture its image, and using tracker you can actually measure the bend, and by measuring the bend you can analyze about the refractive index of the medium. Or another thing that you can do in this is, if you have this water container, and if you have, let's say, one mirror which is kept at the bottom of it, small piece of mirror, then what you can do is you can actually mount your laser on the top such that this laser light is going in, and here you can keep a mirror which you are able to twist. How you can do it is, one simple way that comes to my mind is, let's say you just attach a thread to it and it is coming out from here, and you just pull it from this side. More you pull, more will be the tilt. Why is tilt important? Because if there is a tilt, then depending upon your tilt, it will undergo reflection, and then you can control the tilt such that it is, the angle of incidence is exactly the critical angle. So this is your theta. So you can tilt the mirror till it comes out at a grazing angle. How to observe it? If you just keep a piece of paper on this side, you will see a shiny spot of laser. Okay, that way you can measure it. Or another thing which can be done here is keep on changing the angle of incidence, and you can keep on measuring the angle of refraction here. For that, what you will have to do, before going under total internal reflection, if the angle is well below critical angle, you will have a ray which is coming out. Then here also you will have to put some scattering medium. So put some scatterer in air and in water so that your laser beam is visible, and then you can make the measurements. See, these are the projects which, the more you do, more ideas you will have. So these are just rough few ideas. That's it. Thank you.